Okay, so I want to just take a quick minute and talk to you about plots, sites, multiple different ways of putting it, but how to read one, which can be a little confusing. So I'm going to try to do my best to explain how this works, and we will try to get through this together. Okay, so what you're currently looking at is, sorry, I got a puppy in the background, is a sample of a plat or a plot. It can be called different things. And it's a fairly large one. When you're looking at smaller little normal city lots, it'll be much more compact, and you will have lot and block because there will be multiple blocks of sections of properties that you need is being referenced. This one is just the split of one larger parcel put into another one, and so you'll see it's showing an existing house, and then they were splitting it into, this is a 14,000 square foot lot, which is a pretty standard size, normally around 16,000, and then this one is a 17,000 square foot lot. So it will have point of beginning on almost everything. There are multiple different ways for them to describe how land is done. Many times it will be a walk this way method. So it says like, this is the point of beginning, and it's a well-established point, whether that is a pin in the ground or a monument of some sort that they can reference. So they will start that way, and they will say walking due north 427.6 feet. And then turning due east and walking another 2,000 and I don't know, just any kind of dimension. And those ones get very specific, but it's a little bit more difficult to import that into Chief, but it's definitely doable. It's just can be a little confusing looking at it. So I will show you how, I can show you how that is done. But most of the time, a lot or a plot will come in this survey version. And you will see, like here we're starting at the point of beginning, and we have, this is the hard line, which is the exterior of the property line. The lighter line is indicating a setback or an easement. So on this back here, that's 10 feet in, whereas over here on the sides, it's only 5. So, and then it's 10 on the fronts. And so it looks like 10 is the minimum for a rear, and then in front, and then sides are able to be 5 feet in this particular area. But we want to pay attention to these darker lines. Now this one, cutting through, this is still the same as this larger. So the larger, darker is where the original lot was, and then this was the split that was either proposed or recorded. Now how you read this is in fractions of feet. So this is 179.66 feet, which is equivalent, 0.66 is around, it's 2/3 of a foot, which if you break a foot into thirds, it's going to be 4 inches each. Wow, I don't know why that was so hard. It's late, I'm tired. But so you will be looking at it, that's basically saying it's 179.8 inches long, not 0.8, 179 feet, 8 inches long, but it just does it in a decimal instead. So you're going to specifically type in 179.66 feet for that length. And then this is the part that gets confusing for a lot of people, is how do you read a quadrant bearing dimension, which is what this is. So it is telling you within a quadrant how to look at it. A normal compass is a quadrant bearing system, north, east, south, and west. And so it's cutting it into 4 quadrants. So when you're reading this, It's as if you're staring straight north. Orient yourself if you're going straight north, and then turn your body 89 degrees from north. And then the next number is breaking it into minutes and then seconds. So kind of like a clock hand, because it is a circle. So you're turning, the vast majority of your body is turning 89 degrees over to the east, because that's what it says, the E there. It will also, it can say west. So you start due north, and if it says 89, 44, 39 east, like it does, you're going to turn to your right. Whereas if it said west, you would turn to your left. And so you're going in the direction from north to east. So you go 89 degrees, and then it's breaking each little bit into smaller and smaller sections. So then you go 89 degrees, which you could kind of think about that as hours on a clock hand. So it goes hours, minutes, seconds. So 89 hours, that's obviously not 89 hours on a clock face, but you think about, you move all the way to the hour portion. It's close to a 90-degree angle, as you can see, but it's not exactly a 90-degree angle. So you will go 89, and then the next fraction is 44, and then the next fraction below that is 39. So it's just breaking it into smaller and smaller sections, so you know you're staring exactly in that direction. And then you're saying, you can imagine you are standing at this point of bearing, and they told you this direction to walk, and they told you to walk 179.66 feet. So you, a little imaginary person standing here, you're facing north, you turn the direction that they tell you, and you just start walking along this line until you get to this point, which is 179.66 feet. Now you're standing there, and now you're just going to pivot on that spot again. So if we're looking at this one, that is saying if you're facing due south, so you'll be staring directly opposite of how you started. Facing due south, you're going to turn to your west, so it's still going to be turning to your right, and you are going to only turn 6 degrees this time, and then 21 minutes, and then 41 seconds. So it's not quite as dramatic of a turn. Remember, at the beginning, we were turning almost a full 90 degrees before we started walking. Now we're standing there staring straight south. So it sometimes can make sense to orient yourself this way. Now we're standing here, we're staring straight south, and we're going to turn 6 degrees, 21 minutes, 41 seconds. This is how I've had it explained to me, as minutes and seconds. So some people may say it differently, but you're going to turn just to your right that much, and again you're going to walk 60.40 feet. So and then once you get to 60.4 feet, you're standing on this point now, and again it's saying start facing due south, and you're going to go only 8 degrees, 33 minutes, 35 seconds, but this time it says east instead of the previous one said west, so we were turning towards the west, but now we're going to turn towards the east, which would be to our left. So we're just going to pivot, and then we're going to walk. This is 29.17 feet, and that's how you get to this point. Now, this line, you see this next one, it doesn't have a dimension for what the distance is, but it does. So this really dark, it's saying go the south 8 degrees, 33 minutes, 35 seconds east, 460.64 feet. And that is from this point to this point. But there is a point in the center. And so this smaller number here is saying if you went on that direction, but you only went 29.17 feet, and then you turned, you're at this spot. And then if you continue for 31.47 feet, then you would get to this spot. In total, it's 60.64 feet from this point to this point, but you may need to turn here, which you would need to turn there if you're going to orient yourself for all that. Now you would continue and just slightly tilting yourself, pivoting right and left, and I'm going to turn this back upright. And then, so these ones, you're always starting from facing either due south or due north. They can tell you, it can start with an E and then you end with a S or an N. So that's saying you face due south or due east, and then are you going to turn towards the south or towards the north? It's not as common. Normally they will just tell you the north or south because it's using the due north, that vertical axis, as your main example. When you're doing a walk this way method, because you walked to that point versus having to reorient yourself all the way to north or south, sometimes you'll see that's, well, spin yourself to be due east, and then it'll go off that. So that's how you do straight lines. When you have, especially when you have like a much larger plat and it's all more condensed, this, like right here, L1 is indicating it's a line that's only 1.24 feet long. So they couldn't get this whole bearing in this spot. Sometimes it'll point an arrow to it, but normally it's going to do a line table. So it's just saying that this little tiny section is 1.24 feet long, and then they're giving you your bearing. It looks like the other one that didn't fit is L2, which is only 6 feet long. I'm not even sure where it is. I don't see it. It's probably just about to bite me. It's probably just staring me in the face, but I don't see it. So anyway, it would be labeled for line 1 and line 2. The curve table is where it gets a little more tricky. So that gets us into trig and tangents and chord lengths and all that stuff. So they give you all the information that you need, and like in Chief specifically, you'll just click import arc and plug all the numbers in. You may have to sometimes do it a couple different times to make sure that it's reading correctly. But normally after you've input about 3 of the data points, Chief will automatically tell you what the other numbers are, and you just cross-reference and make sure that they match up. So length is saying on a curve, it is saying the actual length of it if it were more straight, if I understand this correctly. Curves have always been a little confusing for me. The radius is just a normal math from radius. If you drew a full circle of this curve, that is what the radius would be down to the center of the circle. Delta is the change in direction, and you'll see that it's also in hours, minutes, and seconds. So from the start of it to the end of it, there is a change in bearing, a change in direction through that. Chord direction, that's your initial start, and then the delta will be the change in that direction. Chord length is the actual like circumference. So if you were walking on it, that's how long that chord was. And then tangent is if you went off straight, how long that would be. I could talk about this forever and still probably get something wrong because it's a little confusing. But again, use your tools. So just import it into Chief, triple check that after you've put about 3 or 4 data points that they're all matching up still, and then you visually look at it. I normally leave my curves for last, and I will import it somewhere down lower, and then I will point to point move it to where it's supposed to be. So if I were doing this one, I would do all these lines, and then I would draw this C1 over here just to make sure that when I put all those numbers in, if I accidentally had clockwise clicked when it needed to be counterclockwise, it can be completely just shift around the direction that it needs to be, and I may need to input it again. But when I input it, if it looks to be the correct curve, then I just point to point move it, and it almost always matches up perfect, and then it all just closes in the polyline for you. So this is one of the more complex ones. When you have multiple curves, because you very often do, if you have a serpentine, it's going to do this curve and then this curve, and then at any point when the curve is changing with that circuitous, with that path, it's going to give you another curve in the curve table. I have dealt with that a couple times, but normally it will be lines, which is a pretty straightforward, and it's mostly a rectangle. I get some funky shapes sometimes, but normally it's just on the day-to-day basis, it's a rectangle. You can see this one is much more simple. It's just a triangle. I actually imported this into Chief earlier today, and so I just drew a line and it all matched up perfect. I make sure to put the north pointer is the correct direction, and then you can just put it all in. It's a part of a larger parcel, and this is a much older, but it still has a line table and a curve table. You'll notice when it's plats that are much older that come from title, sometimes you can't read the curve table. So you may have to ask, can you guys get me a higher quality image of this? And they'll have to go to their title company, and they're large sheets, they're massive, that they have records of, that they have to go in, find them, go to that correct book page and scan it over to you in a higher quality. Unfortunately, when they were digitizing, it wasn't in the last decade, as they've been digitizing across the country, cameras are just getting better and better, but they're not going back and redoing those. It just doesn't make sense for them to do so. So you can find, like, if I were reading this one, it says 34, I want to say it says 50, and then that could be 06 or it could be 08. It's really hard to tell. But at the very end here, that's not going to change your bearing a ton, but when the number is closer to the front in your curve table, it can make a dramatic change in the whole layout. And when you're dealing with small lots that you can't be touching any setbacks, it's crucial that it is accurate, because you could end up in a setback if the design that you made was touching and then it wasn't triangulated correctly because a curved tape or a line was off. So I see, unfortunately, it's probably about half the time I see the much old school ones, but thankfully this one, they remade it, and it says the sketch is made solely for the purpose of assisting, because this is the official, but it's very hard to read the old official. Like, I can't even really read this, but when I come back up here, I see that it was supposed to say 637.60, and I wouldn't have guessed that's a 6 or that that's a 3, if I'm being honest. So it can be a little bit more difficult. So I know I just threw a lot at you. If you ever have questions, or if you're having trouble reading one, shoot me a message and I can try and talk you through it. And also use it as a teaching moment, because maybe I explain it differently next time. Who knows, but it can be a little bit complex. But once you get it down, it's not too bad, but initially looking at it, you're just kind of deer in headlights. Oh my gosh, what do I do with this? So hope that was helpful, and I'll catch you on the next one.